Far out in the cosmos, a ghostly galaxy stands alone. It shines with only a faint glimmer of starlight and has hardly changed at all for eons. And astronomers have absolutely no idea why it's there or how at all it even formed. DGSAT I, discovered in 2016, is an ultra-diffuse galaxy, UDG, meaning it is as big as a typical galaxy but gives off very little starlight. And this strange galaxy seems to break many of the rules that govern even similar UDGs. Most other UDGs, a concept that is still relatively new to astronomers, are found within crowded, roiling galaxy clusters. Astronomers believe that violent collisions within these clusters split these faint galaxies out like confetti from a cosmic party popper. But the DGSAT I is all alone. Untroubled by galactic collisions or any other kinds of cosmic upheaval, it has probably changed very little since it was born, as per a statement from the Keck Observatory in Hawaii. Because the DGSAT I is a rare exception of a UDG found away from a cluster, it can provide a clearer view into the past. There has not been much activity around it that could taint its composition and evolution. In order to find out what caused this galaxy to be so sparse in starlight, the team used KCWI to map the composition of the galaxy. Aaron Romanowski, a UCO astronomer and associate professor of the Physics and Astronomy Department at San Jose State University, has this to say. The chemical composition of a galaxy provides a record of the ambient conditions when it was formed, like the way that trace elements in the human body can reveal a lifetime of eating habits and exposure to pollutants. DGSAT I surprised researchers with its chemical makeup. Today's galaxies typically have more heavy elements in them, such as iron and magnesium, compared to ancient galaxies that were born just after the Big Bang. But KCWI revealed that the DGSAT I appears to be anemic. The galaxy's iron content is remarkably low, as if it formed from a nearly pristine gas cloud that was unpolluted by the supernova death of previous stars. And yet, DGSAT I's magnesium levels are normal, consistent with what astronomers expect to find in modern galaxies. This is strange because both of these elements are released in supernova events, and you typically cannot find one without the other. Romanowski said that we don't understand this combination of pollutants, but one of our ideas is that extreme blasts of supernovas cause the galaxy to pulsate in size during its adolescence in a way that retains magnesium preferentially to iron. Measurements also show that this galaxy likely took a long time to form, starting when the universe was very young and continuing to form until at least 3 billion years ago. One intriguing possibility is that some of these ghostly galaxies are living fossils from the dawn of the universe when stars and galaxies emerged in a much different environment than today, said Romanowski. Their birth is truly a fascinating mystery that our team is working on solving. UDGs are a relatively new class of galaxies that were first discovered very recently in just 2015. They are as large as the Milky Way but have between 100 to 1,000 times fewer the stars than our own galaxy, making them barely visible and hence quite difficult to study. From even within these, DGSAT I emerges as a miraculous exception, confounding scientists and astronomers everywhere. The characteristics of DGSAT I suggest that the faint object was formed during a very different era in the universe, back just 1 billion years or so after the Big Bang, making the DGSAT I a living fossil. Interesting, isn't it? If you made it to the end of this video, please go like it and subscribe to our channel